Mr. Paras Desai, who is Director Illuminati Building Solutions Private Limited. So Paras is a graduate of the University of Southern California, USA, has a total of 10 years experience and almost more than 7 years experience in precast concrete industry. He has overseen several precast concrete projects for marquee clients such as JSW Steel, Mahindra Happiest Developers Limited, Prestige Estate, Reliance Industries, and many more. So we have a young dynamic technocrat Paras Desai with us. Today he will be speaking about precast concrete, the simple way to increase the life of your structure. So Paras, I would request you to start your presentation.
Thank you, Suchita, for that very lovely introduction. Today, I'll be talking about the lifetime cost of a structure and how precast concrete can actually help in increasing that life. So let's start with the very basic. We'll talk a little bit about what is precast concrete. I think Shri Surya Prakash ji covered most of it, but I'll just go through the basics. Some of the types of structures that are currently being built in India, how they're built, and how do we calculate something like a lifetime cost. Furthermore, we'll go down and see how cast in situ structures and precast structures really compare when you're looking at the overall life of a structure and some of the advantages of precast as I see it. And then we will wrap it up with the conclusion. So let's start with what is precast concrete technology. It is basically industrialized production, which means that the casting is done off-site, brought on-site, and installed. The most important thing about this is it's a planning driven technology. It is not haphazard. So there has to be enough research and time given to planning. The benefits of that is it is highly scalable and it captures almost all construction technologies that are done off-site. So in a typical construction setup, if we see, you have three main tabs. You have the material extraction, which is your raw material. How is it processed, which is your, you can call it as throughput, and on-site work, which is your output or your final structure. So in the case of precast versus conventional, the raw materials are more or less the same in terms of what we use. So we also use concrete and cement-based concrete. They also use cement-based concrete. Steel, both for reinforcement. So the real advantage comes in points number 2 and 3. So in precast, most of the heavy lifting is done in a controlled environment, which is the factory. So all your structural elements are broken down into pieces and cast at the factory and then brought to site. So site work is very minimal in a certain sense. In the case of cast in place construction, it is the exact opposite, where probably ready mix concrete might be the only manufactured item coming to the site. Everything else is done on site. Your shuttering, your reinforcement placement, your all your notches and openings that need to be placed. So that's the real difference between the two in a construction method perspective. Now, if we come to the certain types of structures that are really taking off in India, you can basically boil them into two brackets. One is build and sell model. So you have single story dwellings, multi-story dwellings, basically residential. And you have a build and operate model, which is now picking up steam in India. So you have data centers, warehouses, office buildings, parking lots, n number of structures that are build and operate, where the developer or a third party is tasked with managing that structure for the rest of its usable life. So a quick synopsis is warehousing is slated to grow at a CAGR of 19% over the next 5 years. Hospitality, 13% over the next couple of years. Data center capacity is expected to double in the next coming couple of years. So if we look at the current building processes and what we believe is wrong with it, the structures are designed to be cast in place, minimal detailing and very over or just overarching kind of a design. The majority of the work is site based, so any changes, any small things go wrong, everything has to be handled at the site level. Concrete is produced off site, so either at an RMC plant or at a local site based plant, which is not the same as having a proper manufactured RMC. Reinforcement and all your shuttering, labor work, everything else of the site is carried out on the site. So as you can imagine, this becomes a very, very crowded and a dense kind of an environment. So it is but natural that there will be some slippage of QA/QC when it comes to these kind of structures. Now, if we move and see how does precast differ from that, the structures we place as precasters place a lot of emphasis on the designing and the detailing. The detailing of the structure is critical because all your joints, everything need to be detailed and planned way in advance before your casting actually starts. Then the elements are cast at the factory. Now, the benefit of the factory casting is that you get QA/QC at every step of the way. From the time your raw material comes to the factory to the time that you actually convert it into an actual precast element, there is a lot of QA/QC checks along the way. when you strip it, when you store it, when you cure it. All those things go through several QA/QC norms. Once that's done, the elements are safely transported to the site and installed using a crane. The jointing material, as per what is mentioned in the design, is properly done and filled and readied, and the structure is finished and handed over. The benefit of precast is that QA/QC is carried out throughout the value chain. Materials and different kinds of technologies are used, such as couplers, such as grouts. These things are used to enhance the overall finish and quality of the entire product. Now, this is important because if we look at now the lifetime and the serviceability of a structure, what we notice is that in a typical structure over a period of time, because of poor workmanship, because of poor quality, because of poor planning, n number of reasons, you start to see damages appear in the structure. Now, if there are damages that appear in the structure, the cost of repairing them is very high. Furthermore, as you repair and patchwork a structure, you automatically bring down its usable life. So what we tend to see is that over the serviceability period of a particular structure, the costs start to exponentially rise as the structure ages. This happens in the current situation. Now, if we come to a life cycle assessment, why we should carry this out. So first and foremost, what is a life cycle assessment? It is basically an assessment of the life cycle of an entire structure. One of the most important things is it's an excellent way to understand the environmental impact and the environmental footprint of your structure. So certain studies were done around the world because there's not enough data available here, where they say that nearly prefabrication or precasting can reduce your construction waste by almost 2.5 times. Now that has a huge impact on your overall cost and your overall lifetime cost of a structure. Furthermore, your energy consumption comes down by 5%, your resource consumption comes down by 36%, your health and damage to any safety related issues comes down by almost 7%, and your reduction and your impact on the ecosystem overall comes down by 3.5%, which is tied into your reduction in resource consumption. So these metrics are very important because what it does is it gives us a sustainable approach to building, which is going to be the future of building in the next, well, not even next, it's here now. Because of the environmental impact, because of the overall structural life and the weather conditions and the weathering becoming so rampant, overall life of a structure and the environmental impact of that structure is very important. So a lifetime cost of a structure is nothing but the cost of the building, which is what you incur immediately, and the cost of maintaining that building for the rest of its life. Now, this can include your periodic repairs and rectifications that need to be done. This can include your structural inspections and your other structural rectifications. And it obviously includes one very important factor, which is leakages and waterproofing issues, which can exponentially damage a structure. So when we discuss these things, what do we look at? What are the variables that affect the lifetime cost of a structure? Now, first and foremost, it is what your structure is built of. You can't make good bread without good ingredients. So if your base quality materials, such as your concrete, your steel, and all your other materials added into the structure are of poor quality, your structure will suffer. There is no way to bypass that. Furthermore, how you use the structure, what kind of wear and tear it is exposed to on a daily basis or on a yearly basis is critical to determine the overall life of a structure. The maintenance a structure has to go through in terms of structural maintenance or other maintenance work on a structure also determines the lifetime cost of a structure. And local weathering and local environment also plays an important role. So if you're close to the sea, if you're inland, if you're near a mountain, if you have heavy rainfall, if you're exposed to different elements, those will have an impact on your structure. And we have to ensure that the structure is designed to withstand those elements. So the reason these costs matter is that, look, if you're in a build and sell model, most people would want to build, they would leave, then it is the society's responsibility or the tenant's responsibility to maintain that building. Now, the downside is they might not have the knowledge, they might not have the resources, they might not have the inclination to actually maintain that structure. In a build and operate model, this poses more of a genuine concern, because in a build and operate model, it is one person or maybe two people who are responsible for not only developing the structure, but maintaining it for the rest of its usable life. Since the commercials are tied in with the maintenance of the building, it becomes a priority for these operators. And furthermore, the clientele is usually high paying. So the value of your structure is going to be predicated on how well it is built and how well it is maintained. So in the case of precast, what we notice is that because we have a superior quality of the base materials, we automatically have an upper hand. By that, I mean the quality of materials is higher, so that the overall structure itself is made and built more robust. We have consistency in the building materials that we choose because of the QA/QC processes that we have built in throughout the entire value chain. When we focus on things like the detailing and the smaller things with respect to the design, with respect to the production and the installation, we get a superior product that is has less chances of failure. With respect to the use of grouts, sealants, and other mechanical joints on site, the serviceable life of the structure increases. The most important thing is because of the high level of planning in precast, what happens is that it is easy for us to foresee where we might go wrong, where there might be a problem and where there might be a failure in the future, and we can try and reinforce that at an early stage. In cast in place, I think I don't have to tell this forum, some of those things or most of those things are not possible. So therefore you are left at the mercy of how the structure behaves, how it is stressed, where there are failures. Those are things that we cannot plan for. Another important part of a structure is obviously the green initiative part of it. Now, why is this important? Is because a precast structure or any structure reacts with its environment, and how it is built plays a very important role on how it reacts with its environment. So, because in precasting, we can reduce our resource consumption and maximize our output. Because it's a factory based approach, what we can do is we can be very experimental with the kind of materials we use. So our concrete can then we can use things like GGBS, microsilica, all of those things to try and increase the life of our concrete, the performance of our concrete, while reducing our overall consumption of resources. Furthermore, things like pre-stressing and some design innovations can help us again maximize our output by minimizing our footprint. If I had to sum up this entire presentation in one chart, it would be this. The precast concrete shows to be the least carbon footprint, the least water footprint, and energy consumption footprint. So this automatically makes us realize that we can extend our output with less input. Now, if I focus on certain materials and why precast stands an advantage, the first and foremost would be concrete. So because we manufacture our concrete in a controlled environment, it is manufactured and poured at the same location over the same time frame for the same duration. So we achieve a higher consistency. Therefore, our concrete more or less performs the same. A homogeneity in the concrete allows us to understand how it will perform and carry out better tests and better understanding of that. Furthermore, because our concrete is manufactured, we have more flexibility to try out different things, to try out newer materials, and to incorporate materials that will increase the life of our concrete. In the curing part, we use things like curing compounds, steam curing, and other curing technologies, which can again ensure that our concrete gets the attention it needs to perform to the best of its abilities. On site, we use materials such as grouts. Grouts are an important material and they are very common in India today. They are basically used to join two precast elements together or used as jointing material. These are high strength, non-string, non-metallic grouts, which then add an additional layer of protection to the precast element. They are not what we do on site, which is a simple, mix of concrete and pour it between two joints. No, that is completely not allowed in precast. Whereas these kind of materials increase the life of the joint and thereby increase the life of the structure. So to sum it up, we can say that because of our QA/QC method, because of our attention to the materials and the base materials we use, and because of the care given to each and every product that you can expect from a manufactured setup versus a cast in place setup, we have, in my opinion, a more robust product. And because we have a more robust product that is well designed, all the faults, as many as humanly possible, are already thought out. The building is built before it is actually built on the computer, so we can know where there are conflicts, where there are problems. We are allowed LOD 4, 5 level of integration. These things increase the ability of precast structures to withstand the time of their serviceable life. So they can extend their serviceable lifetime considerably as compared to their cast in situ peers. The other advantage of precast is it's not limited only to structures. We can use it as footings, we can use staircases, which are part of structures, we can use drains, we can use boundary walls, everything can be done in precast. Now, the benefit of that is the more of our development that is precasted, the more the level of integration, the more the level of standardization. That in itself will give you all the benefits we just discussed of. So what happens is that it's one type of technology that's running the show so that you can feed off each other's efficiencies. This is just some pictures of how a precast structure has come up. So you can see how the elements are more or less finished. The focus on the site is these areas, which means that we don't have to really focus on this. We have to focus all our attention on just these 2 points in this particular case. So that allows us more time to really put our energies and our workmanship into the areas we know might have a problem in the future. So the advantages of precast concrete is that obviously the design part of it, where we focus heavily on the detailing. Most of the issues can be rectified or can be planned for. We know exactly where the weak points are, so we can pay more attention to them and reinforce them and make them more robust. And we manufacture in a controlled environment. So that means that our quality assurance protocols are enforced, which means that we are more likely to get a higher performing element. So, in conclusion, precast concrete is best suited for large scale developments. Superior quality of the materials leads to a longer life. Precast is the preferred construction technology for large projects. We have the ability with precast to scale at a very large level while not compromising on the most basic things such as our quality. It's important to carry out an LCA for your structure because that will really give you the lifetime cost of a structure, which is the real cost of it. So if we can extend our structure's life by not expanding our initial cost, then that is a no-brainer for structures that need to build and operate. Even for the structures that don't, but I'm focusing on that. So precast concrete offers you the advantage of being more energy efficient, offers you the advantage of being more green, using robust new age construction technologies that have a long serviceable life. Keeping these things in mind, concrete technology remains the future of construction in India and around the world, in my opinion. With that, I would like to conclude my presentation. I would want to take this opportunity once again to thank all of you for patiently listening and for SEMCON to allow me this very, very esteemed forum to make this presentation. Thank you all, and I will take your questions.
Thank you, Paris, for the excellent presentation and a very short and sweet presentation. So I'll take the few questions. Mr. Parth Thakur, he is asking about, can you share some example of life cycle cost data of any Indian project?
So unfortunately, what has happened is in India, we don't have a very robust project data. There has been a lot of data and a lot of studies done on this in countries like Canada, in countries like China, where they have ample data. But in our case, precast projects are relatively new in India, relatively. So what happens is that, getting very new data and then presenting it will have no value because like everyone knows structures take time, and for an X amount of time you have to view them, you have to monitor them, you have to gather data. Unfortunately, I have not come across any data that really specifically focuses on Indian projects, but there is ample data available for foreign projects where precast is a more developed kind of a technology.
So Paris, since you talked about the shortcoming in India is the data keeping. So would
Correct.
you suggest some softwares or the systems which are being used now or developed to like BIM or anything which can be used so that people can start maintaining the records?
So that's a very good question, Sucheta. And BIM and these kind of design softwares definitely can be used before the structure is constructed, and it should be used. But after the structure is constructed, there has to be a genuine effort to want to see how long, like that data of how long the structure performs, how many kind of issues arise in that structure. Those things need to be identified and a proper study needs to be conducted. And I think that that will happen now that more precast structures are coming up. You have very marquee companies like Larsen and Toubro involved in the space now. So I'm sure that there will be a lot of data coming our way very soon about Indian projects.
Sure, yeah. So another question is, what will be the difference in cost between traditional formwork and precast application?
No, I mean, the cost is very readily available. And honestly, the cost is something that is a very loaded question, which I don't think one seminar is enough to cover. But I'll be brief. Precast concrete is not costlier than cast in place. Like I mentioned, cost is something that you need to take for the overall project and or the overall structure. You cannot take it in isolation and compare two costs. So it varies from project to project, from structure to structure, from location to location. But in my experience, precast concrete does not turn out to be more expensive if you compare the overall cost of the structure in rupee terms to another competitive construction technology. Precast, in fact, if anything, gives you more intangible efficiencies and intangible benefits that people don't usually factor into the cost.
Yeah, right. Yeah, thank you. And I'll take one more question. So, what are the health monitoring techniques that can be used in precast technology?
So health monitoring, I mean, usually it is related to the health and safety of the people involved in the project from the time of construction to the time of installation at site. And health and safety is a very important topic today, and it is something to be considered because there are two things. A, normally at a construction site, like there is a lot of pollution and all that is created, which comes from construction sites. So people working in those areas technically fall under very hazardous conditions. In the case of precast, because it's in a factory environment, it's much easier for us to maintain pollution controlling and all of those things in our factory. So that improves the health and wellness of the people working there and in the surrounding neighborhood as well. Furthermore, being a factory environment, there are certain safety protocols that need to be followed. Those safety protocols are followed at our yard and at our sites. So what happens is that the chances of injury or something worse are much fewer than what you would technically see at any normal construction site.
Yeah. Okay. So thank you, Paras.
We have a small presentation from our silver sponsor, Dexter India. So I would request Mr. Satish Priyadarshan, Precast Product Line Manager, Dexter India, to come on the stage and deliver his presentation.
Thank you for this opportunity. I am Satish Priyadarshan. I am the Precast Product Line Manager for Dextra India. This presentation is going to be very brief, and thanks for all the speakers who have in depth explained about coupler, its functionality, how it's used, where it's used. So basically all that thing has been done, and I would be just giving out references of where it is used. So some of our project references are here. So as in all couplers, couplers are used for rebar connectivity to connect one rebar to the another. So we have a threaded coupler, range of couplers, we have grouted couplers, we have crimped and bolted couplers, which are essentially doing the same thing, providing rebar continuity. So these are all the functions, and you can see this is our precast product line, wherein we have three varieties of coupler. Essentially, a larger variety of grouted, a smaller variety of grouted, which is used for slim sections, and a fully grouted coupler, which is recently introduced. So these are some of our project references. In India, we have done work with Arbindo. This is Galaxy Tower. It is 24-story building, and this is one of our best examples. As in this building, the total construction time was around 11 months only. And this is one more project from Arbindo. This again is a 24-story building. And the coupler being a flexible option, it has also been used to in 2D as well in 3D. So this is a 3D pod which has been done for Suraksha Smart City. And this is a mass housing section which is done in Philippines, a highly seismic area. So in India, the couplers that we manufacture are also exported to India, Middle East, Africa, in US. So it's one solution which multiple codes. And this is a CIRCO project, a mass housing project in Mumbai, where our project couplers are getting used. And apart from residential and commercial buildings, refineries are one area where coupler is effectively used in pipe support frames. Entire Jamnagar refinery, they have been using our couplers for pipe support frames. And this is how the frames look like. Being a heavy precast element, weighing up to 50 or 60 odd tons, this becomes an effective solution. Crowtech becomes an effective solution. Recently, we have entered the infrastructure project, which is for bridges. The struts which are coming out from the segment is connected with the grouted coupler. This is one odd example. And when you talk about applications, we are also entering water tanks. So water tanks is getting done in precast, and we have done a few mock-ups for water tanks with grouted coupler. And when we talk about precast, it's all boxes. And this is one rare example where this is a precast building. It's in UAE, and it's done with the grouted coupler. And this is how flexible the grouted coupler is. You can integrate in any kind of a design, and it is code compatible. So these are all the different, these are our customers who have trusted us and given us the opportunity to work with them. So we are thankful to all these people, and thanks once again.